Lesson 8, Day 3, Identifying Linear Functions. Predict. The cost of a school photo package includes $40 for the photo shoot plus the number of photos ordered multiplied by the price per photo. Is this situation defined by a linear function? Predict the answer and then write and graph an equation on another sheet of paper to check your prediction. You can use $250 or any other value as the cost per photo. So if the cost per photo is $250 and it's $40 for the photo shoot regardless of what package you get, and the number of photos is multiplied by the price per photo, how much is it going to cost altogether? So you'll have your Y equals your $40 plus your $250 per photo. So this, of course, remember, if we're trying to see if it's a linear function or not, it needs to be able to be written in the form of Y equals mx plus b. M is our rate of change, and b is our initial value. Well, our rate of change here is going to be our price per photo. And then our x is going to be our number of photos, while our b is the photo package. Which is the photo shoot, sorry. Okay, and so can this be written in the form Y equals mx plus b? Yes, all I would need to do is just swap the price per photo and the number of photos and the photo shoot cost. So Y equals 250x plus 40. Can it be written in mx plus b? Yes. So this is a linear function. Okay. Number 10, evaluate. Read two students' answers to a math problem. We have Emma says y equals 10 minus 2x is not a linear function because the graph has a negative rate of change. And then Georgia says the y equals 10 minus 2x is a linear function because it can be written in the form of mx plus b. So let's look at Georgia's. And she, like what I did on number 9, she just swapped her rate of change and her input with her initial value. And she had her negative 2x here in the front and then her initial value as the plus b in the back. So she just used the commutative property, which is awesome. You're supposed to do that. That's what I did. Emma said, well, no, it's not going to be linear because it has a negative rate of change. If it has a negative rate of change or not is not what we're looking for in order for it to be a linear function. All we're looking for it to be a linear function is if it can be written in the form of y equals mx plus b. So Georgia is correct. Georgia is correct because all we need to do in order to tell if a function is linear or not is we need to check and see if it can be written in the form of y equals mx plus b. So we agree with Georgia because for a function to be linear, it needs to be able to be written in the form of y equals mx plus b. It doesn't matter if the m is negative. Okay. 11 says create. Write an equation that is not a linear function. Remember, we just said that it'll be a linear function if it can be written in the form of y equals mx plus b. So let's just let's just write one that is not in that form. So you can have y equals x cubed plus 8. Okay, the reason it's not a function is because we have the x cubed, which if we it won't end up giving us a constant rate of change. So it will not have no constant rate of change. And we could prove that by just drawing or creating a table for this. We could have our x's and our y's have our -2, -1, 0, 1, and 2. If I had -2 cubed is -8 plus 8 is 0. -1 cubed is -1 plus 8 is 7. 0 cubed plus 8 is 8. 1 cubed plus 8 is 9. And 2 cubed plus 8 is 16. So to get from 0 to 7, I add 7. To get from 7 to 8, I add 1. To get from 8 to 9, I add 1. Then to get from 9 to 16, I add 7. So I won't end up having a constant rate of change both times, or any of these times. Okay? My rate of change is continuously changing. That's pretty much the only thing that's constant, is that I don't have a constant rate of change. So I have plus 7, then plus 1, then plus 1, then plus 7. No. I would need to have all of my differences to be the same, but they're not. Okay? Then I'm going to move on to number 12, which is our last one, which is part 1, or part A and B. Graph each pair of functions on the same grid using x values of 0, 1, 2, 3, and 4. So we have our first one of, and I'm going to change this pen, of y equals x plus 1, and then we have y equals 2x plus 1. And they said to use 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. These are our x's, and then we need to find our y's. X's, y's. Okay? All right, so when x is 0, so we have y equals x plus 1. So 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3, and so on and so forth. 2x plus 1. 2 times 0, 0 plus 1 is 1. 2 times 1 is 2, plus 2 is 3. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. And 4 times 2 is 8, plus 1 is 9. Okay, and let's go ahead and graph that on the same one. Make one of them pink and the other one a different color. Okay, so we have 0, 1. So 0, 1. 1, 2. 2, 3, 3, 4, and 4, 5. So we have our pink line. And then let's make our other line yellow. We start off as 0, 1, and then 1, 3, 2, 5, 3, 7, and 4, 9. So clearly the second one has a much steeper, it's a much steeper line, so it has a higher slope or higher rate of change, which obviously you can see here the rate of change is 2. Okay, and then it says do the same thing for function B. So let's go ahead and do that. So we have x plus 3 for our first one equals y. 0, 1, 2, 3, 4. And then we have y equals x plus 4. Okay. So, for the first one, x plus 3. 0 plus 3 is 3. 1 plus 3 is 4. 5, 6, 7. X plus 4. 0 plus 4 is 4. 5, 6, 7, 8. Okay, easy enough. All right, and then we're going to go ahead and do the same thing and just plot our points. Yep. So we do the first one, 0, 3, 1, 4, 2, 5, 3, 6, 4, 7. We have our line. We're going to do the same thing for y equals x plus 4. 0, 4, 1, 5, 2, 6, 3, 7, 4, 8. So they have the exact same level of steepness. One of them just started right above the other. All right, and then go ahead and answer these questions. So are the functions linear or nonlinear for function pair A? They are both linear. Do the functions have the same or different rates of change in initial values? They both have the same initial value of 1, but different rates of change. Y equals x plus 1. Our rate of change was 1. But then when we had y equals 2x plus 1, our rate of change was 2. Okay, how can you describe graphs of other pairs of linear functions with the same similarities and differences in the rates of change and initial values? So what they're talking about here is they want us to say that linear functions with the same initial value, different rates of change, start at the same place on the y-axis, but the lines have a different steepness, which is what we talked about at first. So we can just write exactly that. Linear functions with the same initial value and different rates of change start at the same place on the y-axis but the lines have a different steepness. And then part B said do the same thing, answering part in A 1, 2, and 3. Do it for function pair B. So number 1, are the functions linear or nonlinear? Well, they were both linear. 2, do the functions have the same or different rates of change and initial values? Same rates of change of 1, but different initial values. Of course, where we had y equals x plus 3, that initial value was 3. And then when we had y equals x plus 4, that initial value is, of course, 4. 3 and 4. Alrighty, and then our last one, 3, said how can you describe graphs of other pairs of linear functions with the same similarities and differences in the rates of change and initial value? So we could say the graphs, because they have the same rate of change, they have the same steepness, but they start at different places on the y-axis. Those start at. Okay, and that is it for this lesson. So remember, you can easily tell if a function is linear or nonlinear. You can tell that it's linear if it can be written in the form of y equals mx plus b. If the x part is raised to any other power other than 1, then it is nonlinear. So when it can be written like this, it is linear. If it looks like y equals mx cubed or mx squared or anything of the sort, then it is non-linear. Okay? And then again, for it to be nonlinear, that means it has a differing rates of change. All right, and that is it for lesson 8. Make sure you go ahead and practice parts of this in your workbook and other things. All right.